we'll look at one last example to kind of recap everything that we've talked about in this chapter, the hypothesis testing for independent sampling. So each year, the U.S. Environmental Protection Agency, or EPA, releases the fuel economy data on cars manufactured in that year. Below are the summary statistics on fuel efficiency in miles per gallon from a random sample of cars with manual and automatic transmissions. Do these data provide evidence of a difference between the average fuel efficiency of cars with a manual and automatic transmissions in terms of their average city mileage? Use a significance level of alpha equals 0.05. You may assume that the necessary conditions are met. So we're going to hop right in here. First thing that we would have to decide just looking at this problem is, do we have independent sampling or do we have paired sampling? So we would have to make that decision at the beginning of our problem. And the thing I'm going to be looking at is, hey, do the automatic vehicles, is there a relationship between each one of the automatic vehicles in my sample and each of the manual vehicles in my sample? Is there a relationship where every automatic vehicle or car corresponds to another manual car? Based on what we have right here, there appears to be no such relationship. And if there is no obvious relationship, then that means we're going to be working with independent sampling. So this is an example of independent sampling. Once we've established that, we know what our null and alternative hypotheses are going to look like. So for our first step, what is H naught and what is HA? So our null hypothesis, remember, if we're working with independent sampling, is always mu sub 1 is equal to mu sub 2. You certainly could use mu sub 1 and mu sub 2, but I like to, again, just kind of label these. So I'm going to call these mu sub A for the automatic group and mu sub M for the manual group, just so that I can kind of keep them straight as I work through these. The alternative hypothesis then is going to work with the same parameters, mu sub A and mu sub M, so the average mileage for the automatic transmissions and the average mileage for the manual transmissions. And if I look at the language that's being used here, it says, do these data provide evidence of a difference between the average fuel efficiency with manual and automatic transmission? So is there a difference? I'm not claiming that one is greater than or one is less than. I'm just saying, are they different? Which means that we're going to be doing a two-tailed test right here. So we're going to say the population mean of the automatic transmissions is not equal to the population mean of the manual transmissions. So we've got our null and alternative hypothesis set up. Second step would be to, okay, let's go ahead and check our conditions. However, the last sentence right here, it said, you may assume that the necessary conditions are met. So that's great news for me. I don't have to do anything for that step. So there is my first step. There's my second step. My third step then, I would want to go and I would want to calculate my standard error, my degrees of freedom, and my test statistic. If you would like to try that out by hand, you certainly could. However, I'm going to encourage you to use the graphing calculator just because we can be more specific and more precise in particular with our p-value here. The one thing I would say is degrees of freedom, we can go ahead and find that. In this case, degrees of freedom, we have the same sample size for both of these, so it would be 26 minus 1 or 25. We don't have to worry about which one is smaller because, well, they're the exact same. So we have our degrees of freedom. That's all well and good. So we need to know what is our test statistic, which is, of course, going to be a t-value since we're working with the t-distribution. And then what is our p-value? And if we can find those two things, then we'll be set to move on to our next step in the process. So I'm going to label this out based on the way that I've constructed my null and alternative hypothesis. The automatic transmissions, that is kind of group 1 or sample 1, and the manual transmissions, that's going to be sample 2, which means 16.12, that's my x bar 1, 3.58 is our S1, and N1 is 26. 19.85 is our X bar 2. 4.51 is our S sub 2, and 26 is our N2. Again, I do think it's helpful just to kind of lay this information out so that you know exactly what you're going to plug into the calculator here. So, hopping over to my graphing calculator right here. So I'm going to, first of all, go into the hypothesis testing menu. Remember, to do that, we can press Stats, and we're going to arrow over to the right so that we're under Tests. And we want option number 4. It says 2-sample t-test right there. That's what we want. We were given the summary statistics, so we're going to leave it on Stats right there. And then we're just going to type in this information. So X bar 1, we said that was 16.12. S, the sample standard deviation, is 3.58. And N1, we said that was 26. X bar 2 is 19.85. S sub 2 was 4.51. And N2 was also 26. We were doing a two-tailed test. We said not equal to in our alternative hypothesis, which means we want to choose that alternative hypothesis. So mu sub 1 is not equal to mu sub 2. Pooled, remember, we can just leave that on no. We don't ever really need to change that. And we can go down to calculate, and we have a test statistic of negative 3.303 if we round to 3 decimal places. And my p-value here would be 0.002 if I round to 3 decimal places. Make sure you're reading the question carefully. I rounded to 3 decimal places in the last video, so just to be consistent, I'm going to round to 3 decimal places here as well. So hopping back to my problem here, my test statistic we said was negative 3.303, and our p-value would be 0.002. One thing that I want to talk about really quickly, for those that might be a little bit confused about how we determine which group is population 1 and which group is population 2, remember that the calculator always uses the population mean 1 on the left and population mean 2 on the right. So because we set automatic up on the left, that was how I knew I want automatic to be group 1, and then manual was on the right. That's how I knew that manual had to be group 2. So just be careful there. The order does kind of matter a little bit with how you type that into the calculator. You could switch it around if you really wanted to. However, in this case, this was just what happened to be easiest. I wanted to make sure that I talked about that because I know in the last video it was a little bit different just because of the order that that data was presented in. So go ahead and shoot me an email if you do still have questions about that. But we've got our test statistic, we've got our p-value. That means that we're ready to go ahead and make our decision and interpret our decision. Our alpha was 0.05 as usual. So for step 4, we said alpha was 0.05. I'm comparing these two numbers. Is the p-value less than alpha? In this case, yes, the p-value was less than alpha, which means yes, we reject H0. So we will reject the null hypothesis H0, which then means for step 5, interpreting our decision, that means that there is enough evidence to support the claim or the alternative hypothesis. So there is enough evidence to support that, and I'm going to just scroll up so that I can grab that language from my problem, that it said there is a difference between the average fuel efficiency of manual and automatic transmissions. So that there is a difference, between the fuel efficiency of automatic and manual transmissions. sure I didn't miss anything. Automatic and manual transmissions in cars, if you wanted to be a little bit more specific. But there's our process right there. Again, when we're working with these more complicated formulas for, in particular, like your test statistic, I strongly encourage you to use the graphing calculator to find that p-value and your test statistic, just because we can be a little bit more precise. That's what we did when we were talking about two population proportion hypothesis testing way back in chapter 6. So this is going to be one of those problems that I'm going to recommend, hey, you should probably use your graphing calculator for, just because we can be a little bit more precise and because these formulas start to get a little bit longer and easier to make a typo or a mistake in.